Hi students, how are you doing? Welcome back to today's session. Today we are going to solve the numericals of exercise 2A of your chapter number 2, work, power and energy. Today we will solve question number 6 to 11. So let's go to the video without any delay. Come on, you can solve with me. The question number 6. An electric heater of power 3 kilowatt. What is the power given? P is equal to 3 kilowatt. Alright. Is used for 10 hours. What is the time given? Time is 10 hours. How much energy does it consume? Express your answer in kilowatt hour and in joule. So you know the energy is expressed as the product of power and time. All of you must remember the formula. If you remember the formula, half of the work is done. So you have to express the energy consumed, or that is energy is nothing but it is the work done. So we can put the values in the formula. Energy is equal to power. It is directly given in 3 kilowatt into 10 hour. So we are getting it as 3 into 10, 30 kilowatt hour. So we express the energy consumed in 30 kilowatt hour. So that's the first part. The second part, we have to express the same amount of energy in joule. So the relation between joule and kilowatt hour. So 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. So this relation all of you must remember. 1 kilowatt hour is equal to 3.6 megajoule. So if you remember this value, the work is very easy. So we can convert 30 kilowatt hour is equal to 30 into 3.6 into 10 to the power 6 joule. Just multiply it and solve. 30 multiplied with that 3.6 and solve it and express the answer. The answer comes out to be 1.08 into 10 to the power 8 joule. So here you have to remember the key point. 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. Steps are clear to you? Fine. Now question number 7. Look at the screen. A water pump raises 50 liters of water through a height of 25 meters in 5 seconds. Calculate the power of the pump required. And the value of G is given 10 Newton per kilogram and density of water being 1000 kilogram per meter cube. So what all quantities are given there? Volume of the water. Volume of water is given as 50 liter. So convert into SI unit. The density of the water rho is given as 1000 kilogram per meter cube. Then what else is given? Yeah, we have to calculate the mass of the water. So the mass of water is equal to, you know the formula, volume into density. So volume 50 liter can be expressed as 50 into 10 to the power minus 3 meter cube. Alright, 50 liter is equal to 50 into 10 to the power minus 3 meter cube. So mass is equal to volume into density. So volume is given as 50 into 10 to the power minus 3 meter cube into density, that is 1000 kilogram per meter cube. So cancels 50 into 1000. We are getting it as almost 50 kilogram. 50 kilogram. That is the mass of the water. Clear? So 50 liter of water almost approximately equal to 50 kilogram. Or 1 liter of water is approximately equal to mass is 1 kilogram. So remember this value. What do you have to calculate here? We have to calculate the power of the pump required. So power of the pump. So the pump is raising water, 50 liter of water through a height of 25 meter. So power is equal to rate of doing work, W by T. So what is the work done here? See, look at the problem. What's the expression for work done? Students often get confused here. So what pump is raising the water against the force of gravity. So what is the expression for work done against the force of gravity? It is nothing but it is the potential energy. So expression for potential energy is equal to mgh. So W is equal to mgh, that is the work done against the force of gravity upon time taken. Alright. So we can write power is equal to mass, the value is 50 into g is given as 10 into height. The value of height is given as 25 meter. 25 meter. So into 25 divided by, what is the time? Time is given as 5 seconds is equal to 5. So solve it and we are getting it as 50 into 2, 100, 100 times 25, 2500 watt. Clear? So this is the power of the pump required, or that's equal to, we can write 2.5 kilowatt. Clear? Dividing it by 1000. So steps are clear to you. So remember here, what is the key point here? So work done against the force of gravity. Remember, whenever you lift up something, you are doing certain amount of work against the force of gravity. So that work done is equal to potential energy, mgh. So we have substituted the value of work done against the force of gravity, mgh, divided by time. We are getting the power. So this is the key point here. Clear? Steps are clear to you? Is it okay? Fine. Now moving on to question number 8. Look at the screen, read the question. A pump is used to lift 500 kilogram of water. So what is the mass of the water? Mass of the water is 500 kilogram. From a depth of 80 meter. The height is 80 meter. In time is 10 seconds. Calculate the work done by the pump. So how much work is done by the pump? So work done, as you know, 500 kilogram of water is being raised up through a height of 80 meter in 10 seconds. Work is being done against the force of gravity. So what is the expression for work done? mgh. So m is equal to 500 into what value of g is given as 10 into 80. So you are getting it as 5000 into 80. The 5 8s are 40. 400,000. Clear? So I can write 4 into 10 to the power, how much? 10 to the power 5. 1, 2, 3, 4, 5. 5 joule. So this is the work done. So work done by the pump. So that's the first part is over. The second part, the power at which the pump work, the rate of doing work. Power is equal to, you know the formula, work done upon time. So work done, we have already calculated. Place the value of work done here in the formula. 4 into 10 to the power 5 joule divided by time. Time is equal to 10 seconds. Okay. So you are getting it as 10 to the power 4. So you can write it as power is equal to 4 into 10 to the power 4 watt. That is equal to, I can express it as 40 kilowatt. 40 kilowatt. So this is the power spent by the motor in raising 500 kilogram of water through a height of 80 meter. So what's the third part? Part C. The power rating of the pump, if its efficiency is 40%, efficiency is given, eta is equal to 40%. So as you know, 40%, you can write 40 divided by 100, that's equal to 0.4. So you have to calculate the power rating. You have to calculate the power rating. So efficiency is equal to, you know, the formula of efficiency, useful power divided by power input. This is the formula for efficiency which you have studied in the lesson. So we need power input. So power input is equal to useful power divided by efficiency. That is equal to, what is the useful power? So we have calculated the useful power, 40 kilowatt divided by 0.4. So the power rating or the input power of the motor comes out to be 40 divided by 0.4 is equal to 100 kilowatt. So this is the power rating of the motor. So you have to remember efficiency is equal to useful power divided by power input, from which we can calculate the power input, that is the power rating of the motor. Clear? Steps are clear to you? So remember all the formulas, only you have to do the place the values from the question and solve it. Now question number 9, look at the screen, read the question. An ox can apply a maximum force of 1000 Newton. So what is the force applied by the ox? 1000 Newton. It is taking part in a car race and it is able to pull the cart at a constant speed of, the speed is given as 30 meter per second. While making its best effort, calculate the power developed by the ox. Here power is expressed in different context. The force and velocity is given. So you have to remember the formula. Power can also be expressed as the product of force and velocity. Power is the product of force and velocity. So this is a direct substitution question. Force is given, velocity is given. So our work is over. So I can write power is equal to force 1000 Newton into velocity, that is 30 meter per second, that is equal to 30,000 watt. So that's equal to 30 kilowatt. So this is the power developed by the ox. So here you have to remember the power. So power is equal to product of force into velocity. So power is equal to rate of doing work, W by T. Power is also is equal to product of force and velocity. Power also we can write it as mgh upon time in case of when you are lifting a body up. So power will be expressed as mgh upon time. So power as the product of force and velocity. You have to remember all these formulas. Clear? Steps are clear? These are direct questions. These questions are going to be asked in the board examination. Simple, easy questions. Now question number 10. The power of a motor is 40 kilowatt. Power is equal to 40 kilowatt. That's equal to 40,000 watt. You know it. At what speed can the motor raise a load of 20,000 Newton? Load is nothing but it is the force 20,000 Newton. Clear? What you have to calculate here? The speed V you have to calculate. Clear? We know the formula. Power is equal to product of force and velocity. So V is equal to power upon force. So we have modified the formula. The required formula V is equal to P upon F. Now place the values of P here, 40,000 divided by the value of force 20,000. So we are getting it as 2 meter per second. That is the unit of velocity. Clear? So power is equal to product of force into velocity. Remember the formula for power. Product of force into velocity. Is it clear? Steps are clear to you? Okay. On to the last question. Question number 11. Again the same type of problem coming. Rajan exerts a force of 150 Newton. Force is equal to 150 Newton. In pulling a cart at a constant speed of V is equal to 10 meter per second. Calculate the power. Power is equal to, as you know, power is the product of force into velocity. Force is equal to 150 Newton multiplied by what's the value of V there? 10. So we are getting it a 150 multiplied by 10, 1500 watt. The power. As simple as that. If you remember all the formulas, you can easily do the numericals of ICSE class 10 physics. What are the formulas which we used here? Work done. Work done is equal to force into displacement. This is the work done against the force of friction. Or work done is equal to Fs cos theta. When the force and displacement are in the certain angle, this is the force and displacement in a certain direction. Work done against force of friction. Work done against force of friction. Then again we have work done against the force of gravity as mgh. This is against the force of work done against force of gravity. Power is equal to W by T, rate of doing work, that is equal to mgh upon time. Power is equal to again product of force into velocity. So these are the important formulas to be remembered while solving numericals of work, power, energy. Is it clear? Steps are clear to you? I hope by this time all of you are expert in this topic and you can easily solve the numericals. So that's a wrap up for today. Thanks for watching. Thank you very much.